Algorithm. This is a sorting algorithm where we have to sort any array which is given. Like this is the array which is given. So we have to sort in an ascending order. And this is called as a quick sort algorithm. I have also done merge sort and this is the next one which is a quick sort. So as you know, simple sorting is smallest numbers should come at the left side. That is what is sorting, right? The smallest number should come at the left side. So for the quick sort, we have to initialize some of the variables, that is the pivot, then boundary, start and end index. What is pivot? Pivot is any arbitrary number in the array. I have taken at the end just for our understanding purpose. And boundary is before the start, something which is before the start, that is the boundary which is at minus one index. And start is area of I. So area of I is at the start, starting index. That is the start, and end is also at the end of the array. Simple. So there are these particular variables, four variables which we are defining to start our algorithm. Now this algorithm is very simple because it consists of just three steps wherein you are going to swap it and use this again and again. This method is used recursively so that we get at the end we get the sorting array. Let's do one way so that you can understand how to sort it. Okay, let's start. First step is if area of I is less than pivot. What is area of I? Area of I is 15. So I am going to ask, is 15 less than 13? No. So we are not going to do anything. We are just going to continue it. Next, let's take area of I to the next index. Is area of I less than the pivot, that is 6? Is 6 less than 13? Yes, 6 is less than 13. So next step is increase the boundary. That's the reason I'm going to increase the boundary, that is B comes over here. Now swap area of I and boundary. So we have to swap these two numbers. We have to swap these two numbers. So when we swap here, it becomes 6 and here it becomes 15. Just increase your area of I because we have to go in the next index. Now we have to say again the same thing. Is area of I less than 13? Is 3 less than 13? Yes, 3 is less than 13, and that's the reason we are increasing the boundary. We are now increasing the boundary and we are just swapping area of I and boundary. So area of I becomes we will swap area of I and boundary. Now area of I goes to the next index. This is the first iteration which is happening. Again, we will ask, is area of I less than 13? Is 1 less than 13? Yes, 1 is less than 13. So we are going to increase our boundary. We are going to increase our boundary and swap area of I and boundary. So we are just going to swap area of I and boundary. Again, our index increases. Is 22 less than 13? No. We are good to go, so we are not going to do anything. Let's go to 10. Is area of I less than 13? That is 10 less than 13. Yes, 10 is less than 13. 10 is less than 13. So I'm going to increase my boundary and I'm going to swap 10 and 15. So 10 comes over here, 15 comes over here. Now, area of I goes at 13. That's the end of the last iteration. This is the first iteration which we ended. We are not this area of I less than the pivot, it is same only. We are not going to increase our boundary. We're not going to do anything. Again, the next iteration will start. So if you see the my next, this is the one which we got. At whatever we got, I have written just over here for sake of our understanding. So this is just a first iteration. Same thing again we have to do. Again we have to do to get our quick sort array in a sorted format with the help of a quick sort algorithm. This is just the first iteration which I showed you, and it is just three steps of quick sort. We just have to check area of I and pivot, increase that boundary and then swap those numbers. Now here the pivot which I am talking is any arbitrary number. It's any number from this array. I'm just taking the end index for us to make you understand. And boundary is always before the start. And we just have to push basically what the steps we are doing. Why are we swapping? It's just because whatever is smaller, we are just trying to push it towards the left side. That is the main motto of the quicks of the sorting. That's the reason we are doing this. Let's check in the code. So public static, oh, this is caps. Public static void quick sort int array, then quick sort array 0 array dot length. Okay, we are just writing because we need a start and end index, right? So I am defining this as a start index and this as an end index. Now, first thing first, we have to check. We have to check if start is greater than end. If start is less than end, that means it is sorted, right? So we don't have to do anything. If start is less than end, that means it is sorted. So we don't have to do anything. Next, what we have to do is we have to have those four variables. That is int boundary. What is in boundary? We are going to we are saying in boundary is our before start index. So I'm going to define that in form of a method, that is a partition method, because we are going to partition it. Boundary is something which is before the start, right? So I'm just going to define that boundary in form of a method. Then we have two arrays, that is left sorted and right sorted. So left sorted is something which is before start. So if you see, this is the left sorted one. This is the starting. This is called left sorted before boundary, before start. That is the left sorted one. And from pivot till the start, that is the right sorted one. That's how left sorted and right sorted is defined in the quick sort. So let's just define that so that we know we have to move our all small numbers to the left array. So array, what is left sorted? It starts from starting index and it's end at boundary minus one, right? Ends at beyond the start, right? It ends beyond the start. Okay. Next is a right sorted array. What is right sorted array? Partition array. It starts from boundary plus one, right? It starts from boundary plus one and it is till the end of the array. Now let's define this method. What is this method all about? So in this method, I'm defining my pivot as I showed you in the diagram in the Excel sheet. Pivot is something I'm defining as area of n. It is any number, but I'm defining as area of n. And I'm also defining over here boundary. I'm taking this boundary as start minus 1. I'm going to iterate my array. Int of I equal to start I less than end I plus plus. Now I'm checking over here. What I'm checking, if area of I is less than the pivot, then I have to do something, right? Those three steps. What are those three steps? If area of I less than the pivot, then I have to increase the boundary and swap area of start. You can take area of I and boundary. This we have to do. I'm also going to put area over here to help in swapping method. So you just have to swap area of I and boundary, right? That is what you're going to do it. These are the three methods, three lines. Actually, the code lies in these three lines. We are just defining this to understand the partition, left sorted and right sorted, and where we are going to push those numbers. Now let's do the swapping method. Swap is a very easy method where you just have to take a temp variable. So here I'll define this as index 1 and I'll define this as index 2. So this I'm defining index temp equal to array of index 1 and just going to swap now. And I'm pushing array of index 2 towards array of index 1. And then array of index equal to 10. This is my swapping method. Here I'm returning the boundary. So basically we know where is the boundary, we understand where is the pivot, and then we are repeating these steps again and again to, I mean, we are iterating the complete array. This is the array, right? This is an iteration. So we are just completely iterating the array to understand, to push all the small numbers towards left sorted array and from right sorted to left sorted array. So basically we are doing the partitioning, and that's the reason we have the time complexity as O of n log n, and space complexity is also is O of log n. Thank you for watching.